Okay, I just wanted to take a couple minutes to show you how to do the assignment I posted. You're going to want to go to classwork. If you are missing this one right here, Punnett Square Examples. This was due January 26th. As you can see, a lot of people still haven't turned it in. So if you're one of those people, or maybe you were absent and you are forgetting how to complete the Punnett squares, then make sure that you are watching this. So you're going to go ahead and open that up, and this is what's going to pop up. This is going to be a little bit different for you. So there are 9 practice problems and 3 levels. And after you complete a level in class, you were supposed to raise your hand, and I was supposed to come and check to make sure you did your Punnett square correctly. But since you are not in class and you are now doing this at home, you will just have to do all of it on your own and wait for me to grade it. Now, before we start the Punnett squares, you need to understand, I've told you all several times that there are 6 words that you have to understand and know in order to complete the Punnett squares. So you want to go back to your classwork tab, and then scroll down until you find genetics review notes. That's super important. You're going to want to use this on your Punnett square examples, and you're going to want to use this for the genetics test that I'm giving you. So you'll click that, open it up, and I hope this looks familiar. We talked about this in class. This is just a review of everything we talked about during NTI. And honestly, a lot of the questions from your test are going to be from here. So if you scroll down, slide 14 is where we start talking about our Punnett squares. So again, you have to remember a Punnett square isn't showing that a male and a female are going to have 4 children. It's just showing the chance or probability of those kids inheriting or receiving a certain trait from the parent. That's all. So if you go to slide 15, you're going to want to remember these 2. Remember, dominant means that it is the biggest trait, right? It kind of beats up on the other traits. If there's a dominant trait present, that trait is always going to win. And we represent the dominant trait by a capital letter. Okay, recessive, that means it's the rarer trait. That means it will only show up if both alleles are present. You have to get one from your mom, and you have to get one from your dad. Blue eyes, for example, is a recessive trait. You had to have a blue-eyed trait from your mom and a blue-eyed trait from your dad, and those are represented by a lowercase letter. Okay? And then we'll skip 16, we'll skip 17, and then of course, you should definitely remember these 2, especially for your test. When I say genotype, I'm talking about the actual allele combination. Again, you get one gene or allele from your mom, and then you get one allele from your dad. And we represent that with the letters, right? It's always going to be 2 letters because you have 2 parents. Big T, little s, big G, little w. Doesn't matter how you write it. As long as there's 2 letters, that means we definitely know you've gotten one from each parent. Now, the phenotype, that's just the physical trait of the organism. So the genes are represented by the letters, and then when we're actually talking about the actual trait and not just the genes, then that's when we start talking about blue eyes or brown hair or purple skin. You know what I mean? And then for slide 19, homozygous versus heterozygous. So homozygous refers to an organism that has 2 identical alleles. Okay, so big F, or little f. So that means the letters are going to look exactly the same, right? You're either going to have 2 capitals or you're going to have 2 lowercase letters. Okay, that just means that your mom and dad gave you the exact same allele. Okay, it's not going to be different. So if we were to say, hey, you are homozygous dominant for black hair, that means your dad gave you a black hair gene and your mom gave you a black hair gene. And that would be big F, big F. Or we could say the opposite, and you could say, hey, you are homozygous recessive for blonde hair. Well, that means your mom gave you a blonde hair gene and your dad gave you a blonde hair gene. Heterozygous is just the opposite, right? It just means you got 2 different alleles. So you could have gotten a black hair gene from your mom, a blonde hair gene from your dad, right? Two different genes. Now, in this situation, of course, it's different in real life, but in this situation, they don't mix, right? So you have a black hair and you have a blonde hair gene, right? But which one is going to win? Well, we know that the dominant is going to win. We know that big F is dominant, and we know the dominant trait always hides the other traits. So even though you have two different ones, that brown hair one is going to win because it's dominant. Okay, so make sure you understand those 6 words, and then we go back to the Punnett square examples. So let me show you. Okay, so there's 3 examples on level 1, and I am not going to show you how to do those because those are given to you, right? The male is right there, the female is right there. You just plug it into that Punnett square. Same with example 2. I give you the genotypes already. You don't have to do anything. Plug them in. Same with example 3. So let's skip to level 2. Okay, and I'm going to show you how to do this one. So it says a male rabbit is heterozygous for brown fur and a female rabbit is homozygous recessive for white fur. So we know that we're going to be using the letter B. Big B is the dominant trait, and that's for brown fur, and little b is the recessive trait, and that's for white fur. So first we got to create the parent genotypes. So the male rabbit is heterozygous. Well, I remember that heterozygous means 2 different alleles, 2 different letters. So I know that that male rabbit got a big B or a brown fur allele from one parent, and he got a little b or a white fur allele from one parent. So I'm going to go to the next slide, and I'm going to put in my male rabbit genotype. So big B, one from his mom, little b, one from his dad, right? That's what heterozygous means, 2 different ones. So we'll go back, and then we'll put in the female rabbit. The female rabbit is homozygous recessive. Well, I know homozygous means it's the same, and I know recessive is represented by a lowercase letter. So obviously this one is going to be little b, little b. She has 2 white fur alleles. So put the female right here and the other one right here. Okay. It's important that you always make sure that your parent genotypes are correct. If you plug them in wrong, if you put them opposite of each other, if you're trying to separate the parent genotypes, you're going to mess up your Punnett square. So just to make it easier, right, put the male on the top side and put the female on this side right here. Okay. So now all we're going to do is just drag these down, and then we're going to drag them across. So let's start with the big B, right? So now we just put big B right here, and we keep dragging it down, big B right there. And then we'll come over here and we'll put the little b right here, dragging it down, and then we're going to drag it down one more time, little b. And then we'll go over to the female and we'll do the same thing. We just drag her straight across. We don't ever drag diagonally, and we don't ever guess and just start filling in with a bunch of random little b's. Okay? You always make sure that you're dragging them straight down and dragging them straight across. Okay? So the little b is getting dragged across. Dragged across over here. And then we're going to go down to this one and drag across. And then drag across right here. Okay. And then that is it. We just completed the Punnett square. So then we go back. Let's make sure we did everything we're supposed to. So we created the parent genotypes, and then it says create a Punnett square with these parent genotypes. Well, we did it. Perfect. So we can move on. So you'll complete example 5, example 6 the same way. Now, level 3 is where it gets a little tricky, but this is important that you know how to do this because I'm definitely going to ask you how to do this on your test, okay? So it'll be the same thing like the other examples. You have to figure out the parent genotype. So let's go to example 8. Okay, so it says a male and female alien are both heterozygous. We know that the gene is represented by an S, and we know that there's 2 phenotypes, purple skin and green skin. So we're going to create a Punnett square with these parent genotypes. Okay, So again, looks like example 1 and 2, just has a little bit more to it. So let's go back up. Both the male and the female are heterozygous. Okay, again, that means two different alleles. That means the male and the female have one big S and one little s. So again, we'll just go up here. We'll put the male right here, big S, little s. Put the female right here, big S. Oops, that's not a big S, sorry. Big S, little s. Okay, and then just like we did before, we'll come up here, we'll start with the male, and we'll drag him straight down. And then we'll drag this little s straight down. I can turn off my caps. Okay. And then we'll come over to the female, drag that big S straight over. And then we'll drag this little s straight over. Okay, so perfect. We did the easy part. We created our Punnett square. So then if we go back up, let's read the question. It says, what are the percentages for each genotype and what are the percentages for each phenotype? Okay, so let's go back over here and let's see. So we have our Punnett square. We understand and know that this does not mean these two aliens are having 4 little ugly baby aliens. We understand that this is just showing no matter how many aliens they have, this is the chance or percentage of them getting certain genotypes and certain phenotypes. So let's start with the genotypes. Remember, genotypes are the alleles you get from your parents, and they're represented with 2 letters. Well, there's lots of genotypes in this Punnett square. The first one is in this box, right? We'll start with this one. Big S, big S. That's the first genotype. So we'll put this right there. Big S, big S. And then we can go to this next box. Okay, this one is big S, little s. So that's another one that's present. And then here, this one's still big S, little s. We've already counted that. And then this one is little s, little s. Okay, that is 3 different genotypes that the baby aliens could possibly receive. So now we have to figure out, okay, well, what are the chances for each genotype? So let's go ahead and let's look. Remember, there's 4 boxes, and 4 boxes equals 1/4, right? Which is 25%. Easy way to remember this is 4 quarters, right? 25 cents each. If you put them all together, you have $1 or 100 cents. So each box is worth 25%. So big S, that's only 1 box. So that means that the little baby aliens only have a 25% chance of getting that genotype. Well, big S, little s, there's 1 box right here, 1 box right here. That is 50%. That is going to have a much higher chance, right? Several of those aliens are probably going to have that big S, little s genotype. And then little s, that is going to be right here, this last one. And that is also 25%. If you're not sure if you did this right, add up your percentages. If they are more or less than 100, you did something wrong. Okay, so we did that. We finished. That was easy, right? I hope so. So let's go down to phenotypes. So again, what does phenotype mean? This is where you have to know those definitions I told you about. Phenotype is the physical trait. Well, what are the physical traits? Let's go back up and let's check. Okay, that's part of the genotype. This is part of the phenotype. So purple skin and green skin. Okay. So if purple skin is represented by the dominant letter, big S, green skin is represented by the recessive letter, little s, then let's figure it out. Big S, big S. Well, that one's definitely going to be a purple phenotype, right? It's got a capital. It's got a dominant letter. Big S, little s. That's also going to be purple because, again, it has that big S. It has the dominant trait. Anytime there's a dominant trait present, it doesn't matter if there's another trait. It hides it, right? It almost makes sense because the capital letter is so much bigger than the lowercase letter. It could mask or hide that little s. So this one is purple, right? Big S, little s is purple. Big S, little s is purple. So we know that the purple skin, 75%. Now the green skin, it's only going to be a 25% chance. There's only one box that has little s, little s. And in order to have green, that's a recessive trait, you have to have a recessive trait from your mom, a recessive trait from your dad. So you have to have two little s's. So that's going to be 25%. Now, maybe you're thinking this is a little bit confusing because why is there two phenotypes, but there's three genotypes? Well, let me explain. If a baby alien has big S, they're going to be purple. If a baby alien receives big S, little s, they are also going to be purple. Here's the difference though, and you can only see it when these baby aliens grow up and have ugly little aliens of their own. This purple alien, whenever this one has children, alien children, weird looking, creepy aliens. Anyways, when this one has children, this one will only be able to give their offspring a purple gene, right? He has two big S's. That's the only thing he can give them. So no matter who he marries, he can marry a green alien, a blue alien, a red alien. If S and purple are the dominant traits, right, then his children will always receive that dominant purple trait from him. So all of his children will be purple. Now this alien over here, right, big S, little s, just like his brother, will definitely be purple, but when he grows up and he produces offspring, his will be a little bit different. He has two options to give his future children. So he can either give them the big S, right, the purple offspring, or the purple gene, or he can give them little s, right, and that is for the green. So if he were to marry somebody who has a green trait to give, there's a chance that his offspring will be green. Okay. This is what I talked about in class. I hope this helps. This right here is what you will do for example 7 and example 9. You got to have those genotypes, phenotypes, and percentages. If you have questions and you need some help, or if you want me to just check an example, make sure you shoot me an email, please, and let me know if you have any questions.